With the information of being able to calculate the speed of sound, we can define a new dimensionless parameter, and that would be the Mach number. So we define the Mach number, m sub a, as the local velocity over the speed of sound. And that's it. It's just the relationship of your velocity to the velocity of the speed of sound. And so this one is interesting because there's a lot of things that go on with the fluid depending on its Mach number. So let's just talk about the different Mach ranges, the different sonic ranges here. But before we do that, Mach's number is named after Ernest Mach. If you remember, I said you do something cool in fluids that they name a number after you. Mach did a lot of research on planes and flight aircraft. And he did, specifically his research was in shock waves. And a lot of that was about the shock waves that came when an object broke the speed of sound. So let's talk. So subsonic. Got some nice little pictures here from NASA that we're going to use. Subsonic is when you're below a Mach number of when you're below a Mach number of 1. So if Mach 1 is the speed of sound, anything less than that would be subsonic, going less than the speed of sound. So if I was a little person standing right here, those shock waves are moving, those sound waves are moving faster than the plane. I will see the plane, I will hear the plane before I will see the plane, because the sound waves will reach me first because they're moving faster than the plane. What is happening, though, is the stuff in front of the plane, as the plane's moving faster and faster and faster, starts to compress. Kind of gets more dense. So anytime, as a rule of thumb, if our Mach number is less than 0.3, we assume that air is incompressible. We assume that the air is moving fast enough to get out of the way of the plane. After 0.3, though, the air starts to compress because it's not able to move away from the plane quick enough, and it keeps piling up more and more. So we have transonic, which is the plane is flying as fast as the sound waves are moving. I remember when I was taking aerospace classes, my professor used to tell us that you actually could never be at transonic. You could never be at Mach 1. You were either before it or after it. You could go through it, but that was it. There's a whole mathematical proof about that I'm not going to go into because I'm sure I'm the only one here that's interested in it. But what we're interested in is what happens after this. So at transonic, the plane is moving just as quickly as the sound waves. So you basically have, for the lack of a better term, a layer of hard air right in front of the plane that they're just keeping up with. And then the interesting stuff happens when you start going faster than the speed of sound. So you kind of pierce through that layer of hard air and you start dragging the sound waves behind you. Now, this is a very interesting phenomenon. There's a lot going on the plane. There's a lot that's happening to the characteristics on the wing. We'll talk a little bit about that towards the end of the class. And actually, if you look at it, that's why supersonic planes look a lot different than subsonic planes. So your typical carrier planes, commercial planes, the noses and the wings are all big, blunt objects. And if you look at your supersonic fighters, they're pointy. And they're pointy to pierce through that sound wave to drag everything behind you. So now that the vehicle's moving faster than the speed of sound, when I have my little person there, I'll see the plane before I hear it. So it's a very interesting phenomenon that's going on. Now, if you remember, we talked about the continuum assumption. When you go 5 times faster than the speed of sound, that whole continuum assumption starts to break down. So why do you hear the sonic boom? Well, that's because they're dragging that pressure wave with them. So before that sonic pressure wave, pressure is at 1 point. Now they're dragging all of that hard air behind it. They're dragging all of that pressure wave behind it. There's a huge pressure difference between the front of the wave and the back of the wave. It goes down a lot. And so that's what's causing that sonic boom. And that pressure difference is so much that it is possible to damage things, especially windows. I know in the United States, you are not allowed to fly supersonic over most of the country. The military does have some places that they're allowed to practice, that they're able to do things because they have their own little playgrounds. There used to be a supersonic commercial airliner called the Concorde that would fly from New York to either London or Paris, and they were not allowed to achieve supersonic flight until they were a certain number of miles away from the United States coast. So what I have in the next video that you'll look at is a really cool video of an F-18 doing a supersonic flyby of a Navy aircraft carrier. And as you watch that one, I want you to think about the fact that, really notice that you're seeing the plane before you hear it, which is a pretty disturbing thing because it's something that we usually do not see.